Hello and welcome. In this video I'm going to complete a series of tasks for segment routing on OcNOS devices. The task goes as follows. So it says that define an explicit policy. ABC's traffic from R9 to R10 should traverse this exact path. It should go to from router 3 to router 1, then to router 5 and to router 6. Now the traffic is going to be received on router 3, and from there we want to make sure that we have this exact path here. So if I just want to draw it for you, you can see that we are going to send it to router 1, from there to router 5, from there to router 6. Now in a previous video, if you have not watched it, of course I recommend you watch it, but in a previous video what I have done is I have decided that there would be a dynamic policy which uses ISIS, best path to get to destination, and for that we had two different best paths. You can see that this one that goes through here and this one that goes through here, both of them have 2 hops, and the metric to destination for both of them is going to be 20, which means that these are going to be selected over other paths that have more hops to destination. And also in another video I have just decided that I'm going to send the traffic, despite the fact that these are the best paths, I want to send the traffic to router 4, and from there router 4 will decide it. So to send the destination, router 4 of course would send it to here and then to here. And for this we just created a constraint, a strict type of constraint of course. But now I'm going to change this. What I'm going to do is to say that for this type of a traffic that I'm going to send to destination, I need to create an explicit segment list. So segment list is going to be a list of, SIDs, node SIDs more preferably of course, but you can go with adjacency SID as well. And with that, the segment list, I can just say that, for example, the traffic should go to router 1, which is going to have a segment ID of 16,100, then to router 5, which has SID of 16,500, and then to destination, which is going to be 16,600. Now you should know that the number of labels that you can stack up on top of each other for OcNOS cannot be more than 4. And in my case, of course, I'm using only 3, so that's going to be okay. And also, you can do this in another way. You can just say that, okay, I'm going to send it to router 5, and from router 5, it's going to directly go to router 6, because there is only one best path to get to router 6 for router 5, and that would be this. So there are lots of different things that you can do just to achieve this goal. So the flexibility with segment routing is something that we are just trying to examine in this task. So let's just first of all do something. Let's see what we are going to have. Basically, if I just go here and capture the data, and for this I'm going to right click on here and say capture Ethernet 1, and then I'm going to try to generate some traffic on router 9 to router 10. So if I just go to router 9 and hit enter and try to send this ping, you can see that this ping goes, and I'm going to stop it, and you can see that there is none of those echoes visible on router 1. And this should change, as a matter of fact. We are trying to examine this. So let me just close this. And now what I'm trying to do is to go to router 3 to define a policy. For now, you can see that I have just made sure that Ethernet 1 is not shut down. And if I just say show run segment routing, I'm going to show you the previous configuration in which we have a policy which is called dynamic TE. And this dynamic TE policy is attached to the VRF, which is having this router 9 in it. The customer ABC is connected to that VRF. So let's create another policy, and then with that create a segment list. So I'm going to say segment routing, and let me just exit this configuration. So if I just say segment routing, it takes me to segment routing part, and then traffic engineering. And now I'm going to say policy, and the policy is going to be explicit. And let's say that explicit, and the list of stops are going to be 1, 5, and then finally 6. So the name of the policy could be anything, but I'm just going to make sure that this is called explicit 156. Next is the color, which I'm going to define. Let's say that the color number could be anything. Let's say I'm going to say color is 100. You can just assign anything, but let's go with color 2. Why 100? I'm just going to go with color number 2. And then endpoint, of course, is going to be 6666. This is the final destination, and 6666 is connected to my CEs. So I'm going to hit enter, and then I'm going to define an explicit segment list. So if I just say segment, and I just need to go out of this, and I should have just said exit SR, but I just went completely out of it. So let's say the traffic engineering is here, not inside the policy. Outside the policy, I'm going to define the segment list, and the segment list, of course, should have a name. Let's say that this is going to be called SL156, and after that hit enter. Under segment list, I can have an index value. This index value doesn't have anything to do with SID or segment ID. What it is kind of a sequence number. When you configure something like a prefix list, you just use a sequence number, right? When you configure an access list, you use a sequence number. Think of index as a sequence number. And I'm going to say index, and I can just use a number, most likely because I want to make sure that I can just edit this and put some other entries inside this. So what I'm going to do is to use increments of 10, for example, or increments of 100. I'm not going to go with 1, 2, 3 because later editing this is going to be harder. But 10, 20, 30, that's going to be easy to just add an entry 11 or 12 or something like that later. So I'm going to say index 10. And after that, I should say segment type 1. This is the only thing that we have for MPLS, as a matter of fact, because we are using MPLS. And the label value is going to be 16,100. That is the first index, which is going to be rather 1 in my case. Later, I'm going to use a segment list of 16,500 and later 16,600. Just make sure that the number of labels are not going to exceed 4. So this is the first one. 16,500. Index number should be different. Let's say 20. And finally, it's going to get to 6, which is going to be entry number 30. Now I'm going to say exit SR list, and I'm going to go into policy. And what was the name of the policy that we were creating before? That was explicit 156. So we just selected that the color is going to be 2, endpoint is 666, and the next thing I'm going to use a candidate path. So I'm going to say candidate path. The first candidate path for this, it's going to use an explicit segment list. I'm not using dynamic path. I'm using an explicit segment list. And the name of the segment list, of course, is explicit 156. So I'm going to say explicit 156, and after that, hit enter. You can see that for this candidate path, I can have a preference. And I'm going to configure this, and I'm going to tell you why I'm configuring a preference here. Because later, I might want to have another candidate path and use that, and the preference could be the same, which means that I would use load balancing in one of the videos. I'm going to show you this. And also, if I use a higher preference, then that path is going to be preferred over this one. And in some cases, I want to have such flexibility just to increase and decrease the preference of a specific path and utilize that. And that is almost everything that I want to configure here. So I need to commit this part. So here there is a problem that says what does it say? It says that the segment list was not found. That's a very funny error that I am receiving right now. Let me see. If I just say show transaction current, I can see that right now I'm using this segment list explicit 156 and the segment list is SL156. Okay, so now I understand what the problem is. So what I'm going to do is to just go under segment routing. Here we have just defined it. Okay, I'll go under segment routing, and under this policy which I have created, I'm going to remove this one. No explicit segment list this, but I'm going to say explicit segment list. The name of the segment list, of course, is not this, but SL156. Okay, now I'm going to commit, and now we have no problem in configuration. So if I say show run segment routing, you can see that we have created the second policy here. And I now need to use this policy for my customer, because previously under the VRF there is this first policy which is used, and that is called dynamic TE. So what I need to do is to just go to here. I'm going to say show run tunnel policy. This is the first tunnel policy that I have created. I'm going to create another tunnel policy here. So I'm going to say exit, and the tunnel policy is going to be explicit TE, and let's say 156, because I'm not so sure about the future. Maybe I'm going to create some more explicit TEs later. And what I'm going to use is the color, and the color number that we just created was 2, and the tunnel type, of course, is going to be SRMPLS. So I created this, and now if I just say show run VRF ABC, you can see that this tunnel is attached to that. I'm going to change this tunnel. So I'm going to say tunnel select policy. This time I'm going to use this one. So I'm going to say commit, and if I just say show run VRF ABC, now you can see that for this VRF the new tunnel policy is applied, which means that now if I say show MPLS VRF table, I should see this tunnel policy used for that, and color number should change into 2. Okay, so let's go back to router 9, and I'm going to try the ping one more time. So if I generate the ping and go to router 3, now I should see that the path that goes to destination should be 1, which is here, and I mean that Ethernet 1 should be sending the ping. So if I just go to capture this, Ethernet 1, you can see that the pings are going through there on Ethernet 1. And then let's see, I'm going to stop this. From 1, it should go to 5. So 5 is going to send it to 6. So Ethernet 1 and router 5 should be carrying the traffic. So if I just go to Ethernet 1 again, and router 5, of course, you can see that the pings are going to go to router 6. And this is the exact path that I am taking. Am I using Ethernet 2 or Ethernet 3? If I just capture both, let's say I'm going to capture Ethernet 3 first of all, because that was the previous path that I was using. You can see that on Ethernet 3, for now, there is no traffic. And if I just close this and go to, let me just close this as well, Ethernet 2, and check that, you could see that Ethernet 2 is not carrying anything. So this means that I am using the exact path to the destination. Let me go back to router 1, Ethernet 1. I'm going to show you something because I just forgot to show you that. This one is very important, and that is the labels that we are putting on top of each other to send the packet to destination. Let's say that this one, for example, I'm selecting. You can see that I am using 16,500. This is the first label that goes to router 1. So that is going to be removed later. And then we have this 16,600 on top, and then 16,500. So we have these labels on top of each other that, send the packet to the destination for us here. So you can see that we are achieving our goal, and we can just send the packet to destination on our desired path. Going back to router 3, if I say, I'm going to save this. If I say show MPLS VRF table and check this, you can see that now the color has changed to 2 for this specific prefix, which is 10, which means for ABC. And the tunnel policy, of course, is using this explicit TE156 that we just configured it, and everything seems to be good and working. I hope this has been informative for you, and see you in next videos.